Welcome to our deep dive today. We're going to be exploring how life first began, not in the, religious sense, but through the lens of science.
That's right. We'll be looking at it from the perspective of replicators and what Dawkins calls survival machines.
And our guide for this journey is Richard Dawkins' book, The Selfish Gene.
Exactly. It's a fascinating exploration of, how life might have first arisen from simple molecules.
So we're going way back in time, like even before the first cells existed, right?
Yeah, we're talking billions of years ago, to a world of just simple molecules bumping around in this sort of primordial soup.
Okay, so can we try to, paint a picture of that for our listeners? What was Earth like back then?
Well, imagine a world with no trees, no oceans, just a warm, kind of soupy mix of all these different molecules.
Kind of like I don't know, a big pot of molecular stew.
Yeah, something like that. And these molecules are constantly interacting, bumping into each other.
And I guess, some of those interactions are going to be more stable than others.
Right. And that's a key point, actually. The universe, it seems, favors stability.
Okay, so what do you mean by that?
Well, think about a raindrop. It's just a bunch of tiny water molecules that stick together really well.
Right.
Or a rock, which is made up of lots of strong molecules all holding on to each other really tightly.
So even back then, even before life, there was this sort of drive towards stability.
Exactly. Atoms and molecules were naturally arranging themselves into stable patterns.
Huh. And this is all happening just through basic chemistry and physics, right?
Right. No magic involved.
Okay, so we have this soupy mix of molecules, and the universe is kind of pushing them towards more stable configurations. What happens next?
Well, at some point, something truly remarkable happens. A very special kind of molecule appears, one that could make copies of itself.
Whoa, wait. A molecule that could make copies of itself?
Yeah. It was like a tiny machine that could build another machine just like itself. Dawkins calls this special molecule a replicator.
A replicator. Okay, I'm trying to wrap my head around that. How is that even possible? How does a molecule just, make copies of itself?
It might seem improbable, but, think of it like a mold or a template.
Okay.
This special molecule had a structure that could attract other molecules and sort of arrange them into a copy of itself.
So it's like it has a blueprint, and
Yeah.
it's using that blueprint to build more copies of itself.
Yeah, that's a great way to put it. And this was a crucial turning point because now you have something that can reproduce itself. It can spread its own pattern.
Okay, so this is where things start to get really interesting, right? We have these replicators, they're making copies of themselves, and
And of course, no copying process is perfect. There are always going to be some errors.
right. Like if you're photocopying something, sometimes you get a little smudge or a line that's not quite right.
Exactly. And those tiny errors, those little changes in the copies, they're really important. We call them mutations.
Mutations. Okay, so the replicators are making copies, but sometimes those copies have these little mutations, these little differences. What happens then?
Well, now you have a situation where you have different versions of the replicator. Some are like the original and some are a bit different because of those mutations.
And I guess, some of those differences might be helpful and some might be harmful.
Exactly. Some mutations might make a replicator more stable or better at attracting the building blocks it needs to make copies.
And some mutations might make it less stable or less efficient at replicating.
Right. So now we have this competition starting to emerge.
Competition, like the replicators are fighting with each other.
Well, not fighting in the traditional sense, but remember that primordial soup had limited resources.
Right.
So the replicators that were a little bit better at surviving and making copies, maybe because of those helpful mutations, they started to become more common.
So it wasn't that they were trying to be better, it's just that they were built in a way that gave them an advantage.
Exactly. It was a natural process. Those that were better at surviving and replicating, well, they were the ones that persisted.
Yeah, it's kind of like um, I don't know, a game of survival of the fittest, but at a molecular level.
Yeah, that's a good analogy. And as time went on, these tiny differences, those mutations, they started to add up.
So some replicators became even better at surviving in that primordial soup.
Right. And some even started to develop new abilities.
Like what?
Well, some of them started to build little shelters around themselves for protection.
Wait, they built their own little houses?
Well, not houses in the way we think of them, but yeah, they were like little protective bubbles.
Wow.
And those bubbles, those were like the very first cells, the building blocks of all living things. But that's a story for part 2 of our deep dive.
Welcome back to our deep dive. So last time we left off with these replicators starting to build little protective bubbles around themselves.
Right, like tiny little shelters.
And those became the first cells.
Exactly, the very first cells. And from there, things just kept getting more and more complex.
Okay, so how did we go from like a single-celled organism to, all the amazing diversity of life we see today?
Well, remember those mutations we talked about?
Yeah, the little errors in the copying process.
Those mutations were key because, every now and then a mutation would pop up that actually made a cell better at surviving.
Oh, right. Like maybe a mutation that helped a cell get food more efficiently, or maybe made it more resistant to, I don't know, changes in the environment.
Exactly. And those cells with the beneficial mutations, they would, they would thrive.
They'd make more copies of themselves, and those copies would also have that beneficial mutation.
Right. So over time, these beneficial mutations would spread through the population.
And I guess, like over billions of years, those little changes would really add up.
Oh, absolutely. It's like, imagine you have a recipe, and each time you copy it down, you make a tiny little tweak. After a while, you might end up with a recipe that's quite different from the original.
And maybe even tastier.
Exactly. And that's kind of what happened with life. Those tiny mutations over vast stretches of time led to huge changes.
So how did we get from like single-celled organisms to, plants and animals and all that?
Well, one of the big steps was cells starting to cooperate with each other.
Cooperate, like working together.
Yeah. Instead of just existing as, lone cells, they started to form groups, little communities.
And I guess like in those groups, different cells could start to specialize, right?
Exactly. Some cells became good at, let's say, getting energy from sunlight, which is what plants do.
Right.
And others became good at, moving around and hunting for food, which is what animals do.
Wow. So all the amazing complexity of life we see around us, it all goes back to those tiny replicators in the primordial soup.
It's incredible, isn't it? And those replicators, they're still with us today.
What do you mean?
I mean, they evolved into the genes that we carry inside of us right now.
Whoa. So those replicators are like our ancient ancestors.
In a way, yes, they're the blueprints for building and maintaining our bodies.
But if we're just like walking, talking collections of genes, does that mean we don't have any free will?
Now, that is a very good question, and one that we'll be tackling in the final part of our deep dive.
Welcome back to our deep dive into the selfish gene. We've been talking about, these replicators, these genes, and how they kind of drive the whole show.
It is pretty wild to think about, yeah.
Yeah.
And as we wrap things up, I think it's important to address that big question you raised before.
Right, the whole free will thing. Like, if we're just, vehicles for our genes to make more copies, do we really have any say in, who we are and what we do?
It's a question that a lot of people grapple with. I mean, Dawkins himself even talks about it in the book.
Yeah, and it's a bit unsettling, right? Like, maybe we're not as in control as we think we are.
It's definitely something to ponder. But here's the thing. Our brains are incredibly complex. Like, they're not just simple machines carrying out a set of instructions. They're constantly learning, adapting, making decisions based on all sorts of factors.
So it's not like our genes are literally dictating our every move.
Not exactly. Think of it more like your genes provide a framework, a starting point.
Okay.
But then throughout your life, you build upon that framework. You learn, you experience things, you make choices, and all of that shapes who you are.
So it's like our genes give us the ingredients, but we get to decide what kind of cake to bake.
Yeah, that's a great analogy. We have this incredible capacity for learning and growth and change. We can choose to be kind, compassionate, courageous, even if, our genes might be whispering in the background, hey, look out for number one.
So it's like like a partnership. Our genes give us a foundation, and then it's up to us to build on that foundation and make something of it.
Exactly. We're not just puppets on a string. We have this incredible gift called free will that allows us to make choices and shape our own destinies.
That's definitely a more empowering way to look at it. So even though, we learned that life started with these tiny replicators that just wanted to make copies of themselves, the story of life is actually much richer and more nuanced than that.
Absolutely. And I think that's what makes science so fascinating. The more we learn, the more we realize how much we don't know.
Well, this deep dive has definitely given me a lot to think about. We started with simple molecules and ended talking about free will and the meaning of life. It's been quite a journey.
It has. And if anyone wants to explore these ideas further, I highly recommend checking out The Selfish Gene. It's a challenging read, but it's definitely worth the effort.
It'll make you look at the world in a whole new way. And hey, Maybe the next time you see a bird building a nest or a flower blooming, you'll think about those ancient replicators and the incredible journey that led to all the amazing life we see around us.
It really is remarkable when you think about it.
It is. Well, thanks for joining us on this deep dive into the selfish gene. It's been a pleasure exploring these ideas with you. Until next time, keep those brains buzzing.